solar storms and relentless solar winds continuously batter the surface of Mars. Human activities have caused major changes to Earth's environment and atmosphere. This process doesn't just alter the surface of Mars. At the same time, it also provides invaluable insights into the interactions between the planets and the central star of the solar system. This data was meticulously recorded using NASA's state-of-the-art scientific equipment. Currently, it is operating on the surface of Mars. In recent weeks, the Sun has been extremely active, bombarding Earth with intense waves of radiation and streams of particles ejected from plasma eruptions. These storms can generate auroras, and even more severely, disrupt or paralyze radio systems. The positioning system or power grid in affected countries may be disrupted for several hours. Scientists warn of an increase in solar storms. This could lead us to face many new challenges in protecting technological devices and maintaining global connectivity. On May 20, 2024, an energy explosion occurred on the far edge of the Sun. The explosive nature at the X1-X2 level makes it one of the most powerful solar events ever observed. However, Earth is not the only planet affected by this activity. Even at a greater distance, Mars could not escape similarly intense attacks. Even stronger due to the weaker magnetic field and atmosphere of the red planet compared to Earth. Without this protective layer, the surface of Mars would be directly exposed to high-energy particles and radiation from solar flares. High-energy particles can cause extremely intense ionization in Mars' thin atmosphere. This alters the chemical composition of the air while also causing intense ultraviolet radiation. This is the scientific equipment installed on NASA's unmanned Mayborn probe. Researchers have recorded a phenomenon similar to electrical storms as multiple waves of particles collided with the surface of Mars. The radiation detector on the Mars rover Curiosity also recorded a radiation level increase of up to 8,100 micrograys, equivalent to a series of 30 X-rays. This is the highest spike ever recorded by a Mars rover. According to NASA, this measurement provides critical data that helps scientists accurately assess the radiation environment on Mars. From there, they will develop specific strategies to protect the crew against similar conditions. Scientists warn that we are entering the period of the Sun's most intense activity. This means the number of storms will continue to rise. In the future, if astronauts land on Mars during a solar storm, they will have to seek shelter in well-shielded areas to avoid the intense radiation, as this planet has almost no natural protective layer. The astronauts will have to use structures made from highly radiation-resistant materials such as polyethylene or advanced composite materials. These shelters could be located deep underground, where Martian soil and rock would help reduce radiation levels. Preparations for responding to radiological emergency situations must include plans for rapid evacuation. Astronauts must be trained to quickly reach the safety zone in the shortest time possible. Mobile radiation protection devices, such as specialized protective clothing or portable shielding equipment, will play an essential role in safety measures. Additionally, scientists are also researching solutions to create artificial magnetic fields surrounding living areas to mitigate the effects of radiation. A strong magnetic field can repel high-energy radiation particles, much like how Earth's magnetic field protects humans from cosmic radiation and solar wind. These magnetic field generating devices can be installed around astronauts' living and working areas, forming an additional layer of safety protection. Additionally, researching drugs and medical methods to enhance the body's resistance to radiation effects is also a crucial direction. Scientists are researching to discover compounds that can protect cells from the effects of radiation while also repairing the damage caused by it. Although there are still many technical challenges to overcome, this remains a sustainable and effective solution to protect astronauts on long-duration missions to Mars. According to a recent study, besides solar radiation, this most anticipated planet for human exploration could also be an extremely harsh environment. According to Life Science, scientists have discovered over 33,000 objects capable of approaching Earth, posing potential future threats. This has prompted space agencies to accelerate planetary defense missions. However, Mars, Earth's neighboring planet, faces a risk 2.6 times higher. A recent international study reveals that Mars is twice as likely as Earth to be struck by asteroids and small meteor fragments. Co-author researcher Zhu Fanfen Zhu from Nanjing University, China explained that the reason is Mars' proximity to the massive asteroid belt. Kappa. To calculate the amount of Kappa on Mars, the research team used a computer model simulating the motion of all 8 planets in the solar system along with approximately 11,000 randomly selected asteroids over a period of more than 100 million years. Then, calculate the distance from each asteroid to the 6 known voids, sparse regions in the main belt where objects may be ejected. The research team has identified approximately 10,000 asteroids located near the empty space region. During the simulation, scientists caused nearby asteroids to either be pushed away or hurtle toward their host star. This drift occurs due to the Yarkovsky effect, a physical phenomenon that influences the orbital motion of small celestial bodies such as asteroids. This phenomenon occurs due to uneven thermal radiation from the celestial body's surface as it rotates on its axis. The side facing the sun will absorb heat and become warmer, while the side hidden in shadow will cool down. When a hot surface emits thermal radiation, it generates a small force opposite to the direction of the radiation. This force can significantly alter the celestial body's trajectory. Simulating the phenomenon of orbital drift is of particular significance, as over thousands of years, it is the primary cause of asteroids moving into gaps in space. When they reach that point, the periodic gravitational pull from Jupiter or Saturn bends the orbits of these asteroids, putting them at risk of colliding with the inner solar system planets. Home to the 4 rocky planets: Mercury, Venus, Earth, and Mars. The simulation results also indicate that approximately 52 large asteroids approach Mars at a hazardous distance each year, with a frequency about 2.6 times higher than the 20 asteroids that typically come near Earth annually. NASA missions may have recorded some similar impacts. For example, the collision of an asteroid with the surface of Mars on December 24, 2021, triggered a magnitude 4 Marsquake, which was recorded by NASA's InSight lander. Although this is not very good news for plans to conquer or build bases on Mars, something NASA and many space agencies had hoped for, it does help clarify the formation process of the inner solar system. Moreover, this serves as a wake-up call for space agencies to devise measures to protect spacecraft, especially those carrying crews in the future, when approaching vulnerable worlds prone to unexpected attacks. This requires an early warning system and effective planetary defense measures to address potential threats from space. Research and development of new technologies, such as unmanned spacecraft capable of deflecting asteroids, or other methods like destroying asteroids before they enter the atmosphere, are being considered as highly promising solutions. Thank you everyone for watching this video.